indeterminate form, that's an issue. Now, technically, that limit is not equal to that because 0 over 0 is an indeterminate form. So I just want you to be careful of putting equal signs there because some AP readers get really ticky about those things. So that's technically not equal to that. All right. So what we're going to have to do is figure out something else to do. Well, if it was factorable, we would know that we would need to factor this. But this is not factorable. So we have, and it says up at the top there, and it's underlined in bold print, rationalization. Remember when we rationalized the denominator? We're going to rationalize the numerator. We're going to take what's on top, and we're going to multiply that. And we multiply by this. What is that called? When I change that sign, I made it plus 2 instead of minus 2. Starts with a C. It's the conjugate. We're multiplying by the conjugate. So this is how you do these algebraically. So this top one, that's the difference of two squares. So I don't have to worry about the middle term. I just multiply first times first. Square root times square root is just get rid of the square root, right? So it's x plus 1, or yeah, x plus 1. And then minus 2 times plus 2 is minus 4. And on the bottom, I'm just going to leave it like this. I can simplify the top a little bit. That becomes x minus 3. Now we have rationalized the numerator, meaning we no longer have a square root in the numerator. So now we can do direct substitution. You just plug in. Oh yeah, the x minus 3 is canceled. Look at it. Go. It'd be 1. Good question. Yeah, when you have the same thing divided by the same thing, it's 1. So now I plug in 3. Get 1 over the square root of 3 plus 1 plus 2, which is 1 over 4. Very good. And that's about where that point is. It should be exactly where that point is, but it's kind of hard to tell on the graph. So, factoring, rationalizing the numerator. Those are things that help us in doing this analytically instead of with a graph. Now let's go back and remember piecewise functions because these are going to come up. Yay. I know, right? It's a wonderful thing. Okay. Piecewise functions. So let's start on the far left. And you're going to start with the constraint first, maybe. The x value here is at, what is that, negative 3? Right? Negative 3, so it's to the left of it, my pink line is. So how would I write that as an inequality? And do it the other way, but yes. X is less than negative 3. Should it be less than or equal to?
No.
Why not?
Because it's not equal to.
Yeah, because it's an open circle. It's not equal to. Very good. Now, what is that shape that I've highlighted pink?
A line.
It's a line. So let's come up with the equation of that line. How do you want to do that? Cricket, cricket, cricket. Personally, I guess, maybe take 2 points and find the slope. You can do it that way. I have that point negative 5, 0. And I have the point negative 8, 3. Double check me. So the slope would be y2 minus y1 over x2 minus x1. You got negative 1. There's your slope. That's negative 1x. Now I just got to find the y-intercept. Yes, it is. How'd you get it? Oh, negative 5, though.
Oh, yeah.
How'd you get it?
Looked at the graph.
You looked at the graph and you just... Oh, no, it's lucky that it ends up being 5 because that's for a parabola. It is negative 5, though. Okay, you can do it this way. We pick a point. I know, let's see, y is 0. The slope is negative 1. X, and this one is negative 5. So B is negative 5. I could have also went down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Like if I had extended it out, I would see that it was negative 5. I could also do it that way. Something else we're doing in pre-cal right now, these piecewise functions. So. Okay, so the next one, I'm going to pick blue. Oops. Let's talk about the constraints first. It lies between some things, between a left and a right. You with me, Faith?
Mm-hmm.
Okay. What does it lie between for x?
Negative 3 and 2.
Okay. Negative 3 and positive 2. Does everybody see that? For the x's, not the y's. Okay, so you write this as negative 3. It's an open circle, so less than x, less than or equal to 2. Now we got to get that equation. That's a quadratic. Right? That means an x squared. X squared, the parent graph. Ooh, this is really going way back. Parent graph usually is here at 0, 0. But this one has been scooted to the left 1 and gone down 6. So that means
Is there like a number in parentheses and number outside?